pick 2000, right? And let's say, okay, we want everything based on 2000 technology. So you can only, ride the bike or you wear the swimsuit or swing the golf club that was, would have been around in 2000, right?
Mhm.
But you can't rewind all these other things, right? And even, so you can't rewind all these other things. And, like, I guess you could unregulate the pools, but you can't undo nutrition advances. You can't do what we've learned about training advances and all that kind of stuff. You just can't take that back.
Hey everyone, welcome to It's a Material World. We're the show that uncovers why material science will change the world. Consider subscribing and hitting the like button down below. It would really help us out. And without further ado, let's get right into it.
Today's sponsor is MatMatch. With MatMatch, you can find materials for your projects in their free database of thousands of metals, polymers, composites, and ceramics. For example, you could search based on a given mechanical property, such as hardness or tensile strength, or simply search by name to find more information about a specific material. You could also find and contact suppliers if you have questions about a certain material, and join more than 2 million engineers and designers who use MatMatch every year. To join, just simply go to matmatch.com and start searching for free today.
Hello everyone. Our guest today is Dr. Kim Blair, the Vice President of Business Development for Rebuild Manufacturing. Dr. Blair has extensive experience in sports innovation as he is the Senior Advisor to the Ray Ewry Sports Engineering Center at Purdue University, and he was the Founding Director of the Sports Innovation Center at MIT. In addition to these ventures, he has also served as a leader in the International Sports Engineering Association, as well as a technical advisor for the United States Olympics Committee. Thank you so much for coming onto the show, Kim.
Thank you guys so much for having me.
Awesome. Well, you've had a really great background. So I guess just starting off, one of our first question is, baseball is known as America's pastime, and the game's rules have stayed pretty much the same for over 100 years. When we look at games these old, what does sport innovation look like?
So in a lot of cases nowadays, sport innovation ends up focusing on fan experience in those spaces. So what you would notice is, maybe the game hasn't changed too much or the equipment hasn't changed too much to the outside observer, but you'll notice that there's been a lot of changes in the way the game is broadcast, for example. So the technology behind some of the graphics and things like that used in baseball, football, a lot of other sports has changed. The other thing sports engineers kind of do behind the scenes there a little bit is make sure that in a case of baseball, that the new products that are brought into the market or new materials that are brought into the market don't have an adverse effect on the game the way it's played. So, for example, in Major League Baseball, obviously, we're still using wooden bats, right? And so there's been discussions and testing around other options in that place. And sports engineers are certainly at the middle of that, examining those issues.
Wow, yeah. I played baseball in high school, so there's definitely that distinct sound between a wooden bat and a metal bat. So it's no wonder why there's so much innovation in that space, I would say.
Well, and it's interesting too, and you bring up the fact of sound, right? I mean, golf is the other ball club impact, I guess, sport, and it's interesting in golf. Research engineers there that are looking for new materials to add into golf clubs and the way golf clubs are made spend a lot of time worrying about the way the club sounds, because that is one thing that if a person is picking it up and trying at a driving range or a store, that sound is one of the very audible is a very audible cue, obviously, but has a big impact on how people perceive the quality of the club.
Right. And same with the fielders in baseball too. If it's a pop fly, you can gauge depth based on how it sounds as well.
That's right.
Cool.
Well, I didn't know that you could do that for baseball. That's pretty interesting.
We got to play wiffle ball together again, David.
Okay.
But yeah, our audience is also very interested in carbon fiber. And when we talked about it in a previous conversation, it seems like carbon fiber has a very storied past in terms of its use in sports innovation. Can you tell us more about the history of how carbon fiber was introduced into the sports industry?
Yes, absolutely. So it's interesting that carbon fiber really, you may look around at all your sports equipment that you have laying around your house and think, oh, it's done purely for the sports industry, but it really wasn't. The first places it got really heavy application was in the aerospace industry, where strength and weight and all the good attributes of carbon fiber products are well known. And really what happened was, at the end of the Cold War, a lot of military manufacturing and military product development was really scaled back. And so for all the companies that supplied the military and had developed all the R&D and the material specifically for the material, had immediately started looking for other applications, other industries to get into, where, directional strength and strength to weight ratio and a whole lot of other attributes of the material would have a significant benefit. And one of the first places they went was the sporting goods industry.
Wow. And so you mentioned carbon fiber has that almost ideal combination of high strength and low weight. So one of our listeners, Alice, was wondering what other types of materials perform best in sports applications, and what characteristics make a material like carbon fiber have a high strength and low weight ratio.
So yeah, let me work my way backwards through this, and I'll probably have to have you remind me when I get halfway through it where we were. But carbon fiber, the strength to weight ratio is because of the composite nature of the matrix, right? So you get the layup of the material itself, then plus the resin that's put around it. So that combination gives you that nice strength to weight ratio. The other advantage is it can be formed in a variety of shapes quite easily. And it can be formed into hollow tubes, things like that. And then obviously the other advantage is the strength. The strength can be directional through the material, right? And so part of the advantage with the weight is you don't need to have extra weight, because you need strength in only one direction. So you don't have to have the extra material hanging there to get that strength in one direction where you may not need it in the other direction. And so that's why you see it optimized. Bike frames are great examples, right? They really alter the layups in the way the bike frames are made, so that you get the right direction of strength in the bike frame without adding any extra material. Other materials that have worked their way into the sports industry, and I know my favorite are certainly advanced textiles for apparel. That's just a game changer. I'm old enough to remember running outside when it was drizzly and 30 degrees in a pair of cotton sweats, right? And that's just miserable. And the good thing is you don't have to do that anymore, because there's been all these advanced fibers that moisture wicking and thermal insulating and all these kinds of things that have made their way into the sports industry and the apparel world. And certainly in the last year, probably have been about all we've worn since we've all been working at home. And so that's had a side benefit as well. The other thing I think is we see a lot of materials in footwear has evolved over the years. Carbon fiber has made it into plates in stiffer shoes. And certainly most recently around the controversy necessarily, but certainly at the attempt at the 2-hour marathon barrier record that brought carbon fiber plates into running shoes. But we've seen them in cycling shoes and in more stiff, like cleated footwear for quite a while as well.
Yeah, so you kind of listed a whole bunch of applications where carbon fiber has been introduced. I guess going back to the original question, what did the introduction of carbon fiber look like? I know we see it a lot now, but at the beginning, was it so easily accepted?
No, not so easily accepted. And it kind of comes back to a few things, right? We've already touched on a couple of those. And one is certainly one of the interesting things about not the golf, but the sports industry in general, is that the rate of refresh of technology is seasonal a lot of times, right? And every new season you're trying to get new products on the market that have a new advantage, or new performance, or something like that, and therefore the time horizon for doing serious R&D a lot in the sports space certainly didn't match up with the decades of aerospace type R&D timeframes. So interestingly enough, when some of these new carbon fiber golf shafts first came on the market, I remember meeting someone at a conference that was in the industry at the time, and they gave this big presentation to the golf industry and said, hey, here's all the performances advantage you can get from the way these new carbon fiber golf shafts are. And they got put up all kinds of information and data and performance analysis and this. And at the end of the presentation, it said, anybody have any questions? And somebody in the front row raised their hand and says, can you make it in blue? So a lot of times, and certainly the sports industry, and I think the consumer, bear in mind this was literally before the internet, right? So bear in mind that I think the consumer in the sports industry and everybody involved has gotten much more sophisticated in understanding of technology and performance, and so I think the consumer is much more educated in those ways, and then also so is the sports industry, and so the R&D cycle of the sports industry is stretched out a little bit. In some cases, they're looking further afield, and the material suppliers and other suppliers to the sports industry have shortened their R&D cycles to more align with the sports industry as well. And then we already talked about this earlier, but certainly when the first titanium golf heads came out and started trying to replace wood, that tink was not well accepted at the impact, and then certainly then you got the kind of the softer kind of clunky sound when the carbon fiber composite heads came in to golf as well. And so there's always a perception of, yeah, it's better, but, does it really provide an overall pleasing form, right? And sometimes it's not just data, and sometimes it's not just science. There's also a customer perception too.
Yeah, so you just mentioned at the end there the different heads for golf clubs. There's been a lot of innovation around golf clubs, and beyond carbon fiber and what you just said, have there been any other major discoveries in the golf industry?
Yeah, I mean, there have been a number of materials that have been put into clubs over the years, and certainly, even some of the basic physics around ball club impact and things like perimeter weighting and how you control the twist of a club head and all those kinds of things have been experimented with and used, and certainly golf has hired its share of rocket scientists literally over the years, discovering ball flight, aerodynamics, materials for golf balls as well. There's been a lot of innovation in materials for golf balls that have been used in golf balls over the years. And now even, there are companies coming out with concepts about, biodegradable, right? Golf tees, for example, get left out and broken on the course. And I know that there was a company, I think they're still out there, that was making them out of a cornstarch material, right? So that they biodegrade, you leave them on the ground and they just disappear. And there's been companies that have attempted to bring biodegradable golf balls into the market because a lot of them end up in the water. Not mine, I can't ever hit mine that far, but a lot of them end up in the water or left in the woods or whatever. And there's the types of more traditional materials and polymers and things like that are in golf balls are designed to be robust and bulletproof and last forever, right? So it's a little bit exactly the opposite of products that you want laying around in the weeds or in the water.
Do you see there being a longer time scale for creating a biodegradable golf ball? Just because, again, you mentioned sound as being a potential factor. It has to sound like it went off the club really well. But if you add this biodegradable component, maybe that sound isn't there.
Yeah, that could be right, and I think there's always this balance of in any innovation world, there's always this balance of trying to make sure that there's enough of a market pull for your products. I mean, certainly you want to be far enough in front of the market if you're an innovator and bringing new products to market to kind of see where the market is heading or where you might be able to take the market. But in a lot of cases, you really need to understand where that's going to go, and so and sometimes wholesale changes like that come from the proverbial top down, right? I mean, if a big organization was going to come out and say, okay, Augusta National now says, okay, all of our golf balls on this club on this course are now going to be biodegradable, right? That would drive the innovation. Now what's going to motivate them to do that? Don't know. I mean, if they want to put a flag out there and say, we're going to be environmentally friendly and we're going to drive this initiative, then yeah, that could happen. It's just, to move markets in a particular direction, that really will require a significant investment in R&D for a company to make a return on that investment, that's going to take a while. The other piece of this I think that's important for your listeners to understand is that a lot of the core material innovations in the sports industry are done by the material suppliers working in conjunction with the sports industry, right? And so if you're a material scientist or interested in material science, or really want to make contributions to the sports industry, there's really kind of two sides to it, right? One side is you can go to work for a sports brand, and you can be on the sports brand side, kind of really understanding how the materials affect the performance of the products that you design and engineer, and then interfacing with the material scientists on the material supplier side to drive the direction of innovation or figure out which products might work. The other side of that coin is you're the material scientist inside the materials company, and you are the one that's probably, and I'm a mechanical engineer, not material science, so if so if I say something wrong here, forgive me, but you're going to be the one that's going to be, changing chemical change and all that kind of stuff to come up with the new materials on the material science side. So it's just good for the listeners to know that as they're thinking about where they want to go in the future.
Gotcha. And one thing that I just remembered was in David and my ceramics class, we learned about metallic glass and how that was momentarily used in golf clubs, but that didn't really go so far because they really hit the golf ball a long way. Do you know anything about that? Can you tell us more about maybe the surrounding factors in that?
Yeah, so certainly golf has been one of the sports that has done a really good job of trying to stay out in front of the innovation pipeline. And they got caught off guard a couple of times, but I think in general what golf has done a really good job of it is not try to overly restrict the innovation per se, but more put a bracket around how that innovation will be, how the overall sport will be affected by the innovation, right? So what I mean by that is golf has all sorts of rules about club head size, for example, and in particular how far a ball will fly off of impact, and that's probably the most important one here to talk about, right? So and there's a reason for that, right? Because they have a whole infrastructure of golf courses out there across the world that have been built with the understanding that a par 5 is going to be a par 5 is going to be a par 5 kind of wherever you play, right? And a lot of that's based on not only the shape of the course itself, but also on the distances, right? And if all of a sudden you're adding 100 yards distance to every shot, you basically overplayed every course there is, and now you've totally changed the sport forever and ever and ever. And so that's the way golf has managed that. And so, and it's not just the materials you learned about in your ceramics class that have come up against this, but it's also been a lot of other materials have been introduced into golf balls or clubs, and as well as veering away from the material science side a little bit. I mean, dimple designs on golf balls, right? And the aerodynamics effect. I mean, that has a huge impact on how far golf balls fly, and so that will have an impact as well.
Okay, so you mentioned how the golf course size really dictates when equipment is maybe too effective for a competitive nature, and that was actually one of our listeners and followers on Instagram's question, Christian. So hopefully that answered your question, Christian. But in other sports, how do they attempt to regulate themselves, like outside of the golf industry?
Yeah, so other sports come at it very differently. There's others that are kind of always trying to play catch up, right? And others that don't necessarily legislate and organize along necessarily what I would call foundational scientific principles, right? So, probably I'm a cyclist, and so probably one of my biggest beefs is with the UCI that has a minimum weight limit on bikes. Right. And it's like, okay, conceptually, I get that. It's like, if you're riding something that is so thin, it's brittle, it's going to fall apart and hurt somebody, particularly the rider. It's like, yeah, I get it. But, it's somewhat of an arbitrary number that's drawn in the sand, and it affects, different size riders differently. And it's not, the weight of your bike is not any indicator of its performance. Right. And its safety margins. And so, that one is a little bit, I think, beside my backwards perhaps. The other one, I think that, if you've been paying attention to the Olympics for a decade or so, in the Summer Olympics, is probably most obvious. Is kind of the whole, since say 2000 up until now, it's 2 decades. The whole swimsuit issue, right? So if you look back and at the 2000, 2004, and I think maybe even 2008, back in that range, all the swimmers were wearing full body swimsuits, right? And there was a whole lot of technology that was going in there that had a lot to do with materials development. First is the overall idea of compression, right? I mean, a swimmer's body is not particularly hydrodynamic, and so a lot of the idea of the compression of the suit was to try to help shape the body to be more hydrodynamic, right, without overly restricting their motion. And so that was an interesting materials challenge, somewhat like the carbon fiber discussion we had, strength in the right direction and there's flexibility in the others, right? The second was how the material actually interacted with the water, hydrophobic, hydrophilic, the shape of the way the weaves were made to get the water flow over the fabric. And again, that had to do with material selection. And then the other one I think a lot of people may not realize is that the suits were also designed to help with the swimmer's proprioception of the water, right? So actually, one of the swimmers would say, I don't want to wear the suit because I can't feel the water anymore. So they actually worked on designing a suit so that it would actually give you more feedback to how your arms and legs were going through the water. So a lot of those factors. And then what happened was, records started falling and falling and falling and falling. And FINA, which organizes swimming, said, "Oh my gosh, we can't have this, and so we need to get some controls on this." So they put some controls around the design of swimsuits, and the buoyancy and whether or not swimsuits could be buoyant and things like that. And then they just kind of got together in a room and said, "Nope, that's it. From now on, it's knees to hips for the guys, and shoulders to knees for the women, and a certain amount of width of the shoulders, and that's it, right?" And so we saw a big change for that, and unfortunately, the swimsuit manufacturers didn't get a very big voice in that discussion, and that's a challenge because in a sport like swimming, that renews itself and gets its stage once every 4 years. That's a huge opportunity from a marketing standpoint for these companies, and these companies contribute a lot of money to the sport, right? And so they've just, an outsider like myself would look at it and say, "Wow, they just kind of, shot themselves in the foot a little bit on this one." Understood the spirit, understood the intent, but probably didn't have enough people in the room to have the discussion when they made those decisions.
Yeah, so you were mentioning, so I believe in the 2004 Olympics, that's when Speedo worked with NASA to design a swimsuit called the LZR Racer. That was the swimsuit you're talking about. But talking about the records side of it, when sports innovation increases so much like the swimsuit does, and you start to break records, I guess from a sports innovation side, is that a good thing? Like that's showing that the material innovation is doing a very good job. But is that like for classes like a good sign that sports is going in the right direction? Do people not like it because now like the people aren't beating other people? It's now the equipment are beating the like past generations.
Yeah, it's hard, and I always take a step back and I look at it two ways. Is in sports innovation and sports engineering, my job is to create what's next, right? And my job is not to. Sometimes my job is to do so, but in general, my job as a pure innovator is to create what's next and not judge whether or not it's good for the sport, right? The other side of that discussion is that as a whole, the sport needs to decide what's good for it, right? And what ends up happening is you get this real virtuous cycle that we talked about swimming, right? And you have the sport and the fan and the sponsor, right? So the sponsor wants access to the fan wants access to the sport wants access to the sponsor, right? And anything you do to get that circle out of whack really causes problems. And so let's rewind the clock back to another sports technology that's not so much material related innovation, instant replay in football, right? Back when that was first introduced, back in the dark ages, before digital TV and everything was digital, right? It made the game so slow that people stopped watching, right?
Mhm.
They just turned away, and the sponsors will say, well, if you aren't putting eyes in front of TVs for me, I'm not paying you, right? And so they threw it out, right? And then the technology caught up to the spirit of what they want to do, and then they brought it back. And of course, now it's everywhere. I mean, and I'm a little appalled they're using it in soccer now, but that's my opinion. Again, yeah, exactly. It's like, what are you doing? You never stop this game for anything. So again, it kind of comes down to really balancing that out. The other piece of this is, and I'll go back to the swimming as an example, right? The other piece of this is pool technology, right? Pools have gotten faster, right? They've done a good job at reducing waves, and both through the lane because of what they do with the walls of the pool, the way to design the ropes so the waves don't cross the lanes, right? That makes a faster pool, right? Mm-hmm. And the other non-material side of it is, the athlete themselves, right? There's science and research going on all the time, physiology and training effect and nutrition and mental and neural and all these things, right? So let's say, okay, well, let's pick a year. Let's pick 2000, right? And let's say, okay, we want everything based on 2000 technology. So you can only, ride the bike or you wear the swimsuit or swing the golf club that was, would have been around in 2000, right? Mm-hmm. But you can't rewind all these other things, right? And even, so you can't rewind all these other things. And, like, I guess you could unregulate the pools, but you can't undo nutrition advances. You can't do what we've learned about training advances and all that kind of stuff. You just can't take that back, right? And even if you look at golf, I mean, you look at the evolution of golf and the size and structure of players. I mean, players have adapted for the sport. And another interesting story I want to share with you. I heard Apollo Ohno speak once, the speed skater, at an event. And, he said, interestingly enough, his success almost ruined his career because what ended up happening was his success brought a new level of spectator, a new volume of spectators to the sport of speed skating. So the venues for speed skating got bigger, which means there was more people in the building, which means there was more lights and more TV and more heat in the building. Mm-hmm. So on average, the surface of the ice got softer. So he was a big, powerful skater, right? And, he's not huge, but for a skater, he was a big power skater, low turnover in his stride rate and a big skater. And what he realized in his second before his last Olympics is he saw the other speed skaters that were doing really well, had a shorter stride, were smaller, lighter because the ice was getting softer, right? And so in his last Olympics, he I don't remember the numbers were startling because he's not a big guy. He dropped like 20 pounds and he increased his stride rate in skating in order to stay, at that gold medal level. He had to totally remake himself as an athlete because, the conditions of the sport have entirely changed.
Oh, wow. That is absolutely wild. Like, I mean, yeah. I remember watching Ohno like during the Olympics. And so he definitely did bring a lot of eyes to the sport. And that's crazy how from the science and engineering perspective, that actually hurt him because of the softer ice, because of the increased heat. But it's cool to see that he kind of revamped his game to adjust for that.
Yeah, absolutely.
Wow. Yeah. And one thing you touched on during that was that the whole sponsors thing. And so going back to the swimsuits, Speedo made that. So I guess in the sports world, when certain companies have innovations over their competitors, how does that affect competition in professional sports?
Yeah, so that's we can talk about swimming, but we can actually fast forward to today, right? And so when Nike in particular came out with their project Sub 2 or whatever they called that project, where they're trying to break the 2-hour marathon, right? So they dumped a lot of R&D into developing new running shoes, right? And they were the first ones kind of to come out with that carbon fiber piece in it, right? And so, as any good innovation company will do, they'll set up a bunch of IP, intellectual property, patent barriers around that, right, to keep other people a little bit at bay. But then, if you start looking through the running press, there was a lot of discussion around whether or not, well, can the other shoe companies keep up? Can the other shoe companies design something to keep up? Can the other shoe companies still attract athletes? Because if you're running a race and you have a perception that your shoe is a minute per mile. So, well, it's not going to be a minute per marathon. It's more realistic scale, slower. That's going to be hard for you to sign up to, right? So all of the companies are doing this, and it's interesting, particularly in regulated sports, right, where each of the, and which is true pretty much in every sport to some degree, right? All the companies are trying to get that competitive edge, right? And the latest, newest material, or a little bit of better engineering or whatever to attract those, make sure that they can keep their stable of top athletes, which of course gives them brand exposure. So it is always a competitive space, and gives innovators a lot of room to have a lot of fun.
Nice. And so we've talked about governing bodies dictating the rules and regulations for professional sports, but there seems to be a whole other industry for just the individual consumer. And so I was wondering, how fast can consumers utilize new technologies? Are there companies that specifically create products for just the casual consumer?
So the answer to your last part of your question is all of them do, right? Because
Right.
quite frankly, when a startup comes out, and I've seen this in startup presentation pitches or whatever, it's like, oh, we've got 5 NFL teams and 3 top college basketball teams or whatever, using or whatever it is we just invented, kind of thing, right? And it's like, yeah, that's a market. And it's like, that's not a market, that's an influencer set. The market's down here, right? The bottom part of the pyramid, right?
Right.
And so a lot of these innovations, what you'll find is they trickle down pretty quickly, right? So the very tip top of the pyramid is where these things come out, right, at the very high price points, and then as the new thing, then they keep taking them down and down and down, right? So I speak to cycling because I ride bikes a lot, but you see what happens, right? So right now, astonishingly, if you want to buy a bike that what would be ridden at the Tour de France, you can buy the same bike off the shelf that's ridden at the Tour de France, right, at your local bike shop, right? That's going to cost you $15,000. That's 15 and 3 zeros, so somewhere in that range, right? 10 to 15, depending on exactly what it is, right? Well, what you'll find is 5 years from now, a lot of the technology, if it's like state of the art, cutting edge technology that's on that bike, will have trickled its way down into the lower price point bikes, right? Now, it's never going to get to the $300 Walmart cruiser bike, right? That stuff's never going to get that far down the chain, right? But it will get down into the mid tier, where the broader, when you're out on a Sunday morning group ride, and you're looking with a cluster of 50 people or whatever, a lot of that technology has certainly started at the top and trickled its way down, right? And so all companies will have that strategy of, we need to have this technology at the top, and then they'll also be thinking, okay, that's great. Now, how do we get it downstream to a lower price point where we'll see a broader adoption across the platform? Or, what else are we doing down here that's getting us the broader exposure across the platform? And maybe it's purely a marketing play to buy more consumers into the lower price point products that can support the R&D at the upper end, right? So the strategy is all tied together.
Is it common to see, like, in the R&D, they find a product, a material, or whatever that maybe it doesn't fit into the rules and regulations of professional sport, but instead they adapt that product for the consumer market?
It's interesting. I'm sure that's happened. Typically, though, consumers, and golf is a great example, right? So there's nobody out there. If you go out and play around at 18 this weekend, there's probably nobody going to come up and like walk through your bag and make sure you're playing
Right.
all accepted clubs and balls and stuff. And you can go out and buy balls and clubs that won't pass the regulations because they are, quote, too good, right? But people kind of have the spirit. It's like, no, I kind of want to use what's out there, right? And so although there's probably a small market for that, people won't do it. Now, that said, I have been approached by companies a couple times, and unfortunately never actually got to do it, where they said, okay, we want to design something so good that will be outlawed, right, by organizing committee, right, or some Olympic committee, right? Well, they were looking at the history of Speedo, and every 4 years there was so much controversy around the Speedo laser racer, right? They got all kinds of press right? And basically free marketing, right?
Yeah.
And so they were looking at that as a way to, and it was a company that really wanted to put an innovation stamp on their brand, right? And so it was a way for them to say, hey, look at us, we're really innovative. We can really get out there, right, and do things ahead of that. And so there is, sometimes materials or whatever it may be that drives that innovation. There are companies that will look to do that, but in general, it's kind of interesting in that because even youth sports has rules and regulations, right, around what they do. They may be different rules and regulations than what you see in a like major baseball is a great example, right? I mean, you will never. We don't see aluminum or carbon fiber bats in major league ball, but we do see them in college and youth and everywhere else, right?
Right. Mm-hmm. Yeah, so I guess we've covered a lot, and we talked about how innovations can disrupt specific sports, but we still see that even in very traditional sports like baseball, they seem to seek ways for ways for players to improve their performance with new technologies like embedded motion sensors in their bats. Can you kind of talk about how this new type of technology is being implemented across the sports industry?
Yeah, so I think wearables in general, and obviously you don't wear a bat, but we'll just lump all those performance measurement on device, on person devices into one discussion, because they kind of all have the same effect, right? So as an athlete, everything is about performance, and anything you can do, and you have so many hours in a day and so much time that you can devote to training for your sport, right? And it's not just because there's only 24 hours in a day. It's because your body also needs to rest and recover to improve, right? And so there's all these cycles that are well known in the physiology world, right? So a big chunk of the wearables world, or the performance measurement world, is to give higher value feedback for absolutely everything that's done, right? Mm-hmm. So to your point about the motion sensors in the bat, right? Now you have a way, certainly with distance monitors, ball flight monitors, and things like that. I mean, there's been a long time to say, oh, well, that ball went this far and had this kind of arc and that kind of hit and things. Well, now you had a motion sensor into the bat as well, and it's now you have more idea about exactly what was going on with the bat as you led up to it, what the swing was like, and that kind of thing, right? And so, if somebody knows what to do with all of that information and make it actionable, i.e., then okay, take 5 bats, hit 5 balls, let's see what happens. And then, come back to them and say, okay, you know what, you need, I'm purely making this up because I don't know what I'm talking about in the space in particular, but you need to, you need to adjust your swing rate so you're coming faster at the start, and then, ease up through the follow through or whatever might make sense, right? But, with some, real fundamental physics-based approach to the problem, right? And that's what the wearable tech is doing for all of this. I mean, another simple example is heart rate monitors, right? I mean, they came on the market in the 1980s, and that was kind of the first time that an individual could have really one-on-one feedback on exactly how hard they were working at any point in time, and then plus the aggregate of what that effect was like over time, right? Mm-hmm. And so again, it allows them to optimize the time they spend on their training to improve, right? And at the end of the day, that's kind of what it's all about, is how do you improve, right? And so, the whole challenge in that space is a few things, right? For the material scientists in the world that understand battery chemistry, we need more of you, because quite frankly, power is the problem in all of these things, right? You still have a coin cell or some kind of rechargeable or something that's in these, and that largely dictates the form factor of all these devices. That's the biggest physical piece of real estate in all these things, is whatever the power piece is, right? So, you battery chemists out there, get busy, because that's going to be really the next stage, not only for those, but for our cell phones and everything else, right? And cars and everything else, right? So that's super important. But it really is, I think understanding, when you get into that wearable space, is really understanding a lot of what we already talked about in whole other places, but what is a bigger market there, right? And who's going to use it? And yeah, it's great. And interestingly, when smartphones came out, they drove the price of all the little component, widgets inside the the GPS, the accelerometers, all those kinds of things inside the smartphone, drove all those component prices down now, right? So, anybody can go out and populate a board with something and solder some stuff up and a little bit of coding and transmitting it off to Bluetooth to your phone or whatever you might decide to use. It's like, hey, look, I can measure this. It's like, well, that's good, but who cares, right? And so in that case, it's really about building the whole value proposition around it, right? So that you really understand what kind of information are people going to need, what's it going to, how's it going to help, not just not just the tip of the pyramid again, but also broader across the whole spectrum, so that you have products to do that.
Yeah, I've actually done like 5 years of battery research, so I love batteries, and I work on those problems. We've talked to a lot of people, and every time someone's got something to say about how batteries need to step up. So I'm hearing you guys loud and clear. I'll work on it. I think what you said at the very end was a very interesting thing. I know we talked about how consumers want to have become more educated and have been trying to tap into these new technologies. So with the wearables market, how does the individual consumer kind of feel about wearables, and is it something very commonplace nowadays?
Yeah, but that's a multi-pronged answer, right? So I think in general, the idea of being able to understand how your body performs, depending on where you are with that, is pretty important to people, and people will pick it up. And it certainly used to be the day that if you got a room full of runners and said, okay, how many of you use a heart rate monitor, right? You get 3/4 of them to say yeah. Right. And they pick it up. And now it's like built into the watches and everything else with varying degrees of accuracy. So I think a lot of people are into that. I think that the challenge is really making sure that, heart rate's a pretty obvious one, cadence and speed and those kind of things are pretty obvious. Some of these other metrics, I think, require a fair bit of interpretation sometimes on the part of the user, on how to get something useful and actionable out of it. And I think that still remains to be the challenge there in that case. The other piece of this, of course, is a whole data privacy issue, and I'm not even going there because it's way over my head, other than the fact that, but certainly if you are an innovator in that space, I mean, that's probably one of the biggest concerns is, understanding data privacy and how you're going to work that into the system as well, because that's a huge thing. And it's interesting too, to see other things that happen, that app developers will put out there and then actually take away one thing or another because they find out, oh, maybe that wasn't such a good idea, right? And so apps that track your whereabouts, for example, right, and then make that even in a very anonymous way, all aggregated, right? So there was a fairly famous issue a few years ago where there was Strava actually had been tracking, people have been tracking using Strava, runs and walks and all that kind of stuff. And they put up what they call these heat maps of where everybody was using and being tracked, right? So the idea being there, it's like, oh, well, let's say you're traveling to a new city and you want to go for a run. Well, where does everybody else run, right? Because that's probably a good place to run, right? And that's, okay, I get it. I do that too. When I go running, I'm just like, okay, well, where can I go run if I'm on travel, right? But the unintended consequence of that was people could use that data, and in South Korea was a great example, right? It's like, oh, there's where all the American military bases are, right?
Wow.
Yeah, just because all of a sudden it's like, after like 2 years of this data, right? It's like, oh, you can kind of just figure out where all these people are. Right. And, so there's just unintended consequences of these kind of things that, kind of, I think, when you mention it in hindsight, it's like, well, of course, but, when you're putting it out there in the first place, it's like, oh, never really thought about that. So that's an issue too, right? But I think really the core message is really understanding, what you're going to do to what value add you're going to do, right? And so, pulling us back to the material science side, I think, one of the biggest things wearables have to do is just disappear, right? They've got to figure out a way to be integrated into everything, to be really successful, right? And, still today, if you really want accurate heart rate, you're putting on a chest strap, right, to get your heart rate. I mean, the wearables that are just on your wrist or other places, they're getting better, but they're still not there. They're still not to where the chest strap is, right? So how do you do that? You're putting on a chest strap, you're putting on something, a wristband thing, that's actually recording that information for you, right? Well, and people have made over the years various attempts to get these kinds of things into apparel or into, stick-ons or whatever that might be. But there's just, a lot of fundamental issues there. And, to be most forward about it, there's hard bits in these things, the battery, back to the battery again, but there's also hard bits in these things and, little printed circuit boards and all this kind of stuff that, are hard to get bendy flexy enough to put into textiles. And also, be thrown in the washing machine and the dryer once a week or twice a week or whatever, and come out the other side and still function, right? To a point that, it's still a compatible price point with the shirt without the stuff, right? And, it's just a lot of basic materials problems to be solved.
Right. Yeah. I remember 5 years ago, I saw that wearables technology firsthand. We were playing baseball, and during the summer, we put like a ring size wearable on our baseball bat, and we were able to see, like you mentioned, kind of that motion sensor. And so we could see the loop if the swing wasn't totally efficient, like straight to the ball. And that was just really cool to see. And that was a way to optimize our swing and improve and even see like the bat speed and everything. So yeah, I'm just wondering, I guess, where that type of motion sensor technology is today, if it was so good even 5 years ago.
Yeah, I mean, that's the other piece of it too, is the wearables thing is, phones and cameras and AI and ML and, all the other acronyms of kind of what I would call, deep algorithm development, right? Are making advances so quickly that a lot of what, that's probably going to be the one place that a lot of it is going to eliminate the need for add-on individual pieces, right? Because if you already have the phone in your hand, you can download an app and put it on a tripod or whatever. That goes a long way, right? But I still think that there's a fairly big gap between what's there now and available now in that space, and maybe the level of scientific or performance level accuracy you really need to get useful information, right? So until that time, we will still have add-on things. The other things about the wearable space too is it's right now it's a pretty wide open field. That's we talked about rules and regulations around this, right? There aren't any really per se, other than data rights thing. But I mean, as far as if you have some kind of device that you're sticking on something and measuring performance of something, there's nobody out there that's saying, oh, that was 28 miles an hour. Is what the thing says. There's nobody out there saying, it's 28 miles an hour plus or minus a tenth of a mile an hour, or it's 28 miles an hour plus or minus 5 miles an hour, right? Nobody out there is regulating this yet. And, I'm not necessarily advocating that we should, but it is, it's a little bit of the, the Wild West, so to speak, and buyer beware and all those kinds of things. And you have to use that information accordingly.
Right. And so it seems like the primary way in which materials specifically play a role in sports innovation is through those collaborations between materials-based companies and the sporting goods industry, right? And so you mentioned in a previous discussion that BASF, a chemicals company, worked with Adidas to create the Boost Foam technology to increase energy returns and comfort in their running shoes. And so I was just wondering, how did this collaboration come to fruition, and what materials made this innovation possible?
Yeah, so I was not involved in part of that project, so I don't know much more from just what I've read online and those kind of things, and from that way. But having worked in and around the sports industry as a consultant in the industry for a number of years, and certainly through the labs at the university labs and things, sporting goods companies are often looking for an edge, and as we talked about a little bit earlier, the engineering and science breadth and certainly deep depth in the sporting goods company is not certainly the level it is at a BASF or a 3M or any of these real materials focused companies that have the advantage of developing materials not only for a sneaker company, but also for a auto company or energy company or another things, right? So they, so they have a lot more resource to throw at R&D. And so therefore, sports companies, and this is true in a number of industries as well, right? I mean, even automotive industry, right? I mean, they're looking to their supply chain to improve materials in their space too, right? So it's very common for collaborations to be developed where there's some deep materials science expertise getting engaged with, call it the closer to consumer product use brand. To develop and co-develop technologies. So what ends up happening there is that in the Adidas side, they would come to the table with a real core understanding of footwear biomechanics and how changes in footwear biomechanics affects the performance of the runner or the walker or whatever it is, whatever the intended use is, right? Mm-hmm. They would come to the table with that kind of understanding. They would come to the table with an ability to be able to measure and quantify the performance of the integrated final unit, right? And understand that and say, okay, here's the menu of things we have now, right? Here's the performance metrics we have now for this menu of materials. And if we can change this one by, 5%, whatever that metric may be, right? Energy return, that's a great example. Let's say we can improve energy return by 5%. Well, that equates to, some number of seconds in a marathon, right? Mm-hmm. So let's try to fix that, right? And then so then, the materials company is like, okay, well, we understand that. So they take it to the fundamental level and say, okay, if we're going to equate energy return, well, you guys are material scientists, you could probably answer this better than me, but we're going to adjust this, that, and the other thing, right, to come up with a material that will do that. And then, the sporting goods company then would have, or the footwear company, and would have the ability to quickly take a sample of that material, integrate it into the footwear, do holistic testing and performance analysis, maybe do some advanced quick wear testing for durability and things like that. And then, in some ways, then they would have to work together to figure out how do we actually manufacture this at scale, at volume, into a piece of footwear, right? And so that's the way the collaboration works all along is each one of them brings their secret, not their secret, but their particular level of expertise to the table. And it's not just materials, but it's a lot of other things, right? I mean, the innovations occurs at the boundaries, right? So, here's the boundary of what the sporting goods company knows or the footwear company knows, and here's the boundary of what the materials company knows. And it's like, okay, how much can we push those together, to come up with some new innovation?
Yeah, that's fascinating. I didn't know that it was such an integrated part of that innovation cycle. But I guess our last question for you today is, with your experience leading multiple companies on the basis of continuous innovation, what advice would you give for our listeners who strive to make an impact in the sports industry through material science and engineering?
I think kind of back up a little bit to what I said earlier, and that is kind of decide. I think you need to kind of decide for yourself. It's like, okay, where do I, how close to the athlete do I want to be? Mm-hmm. Right. And I don't mean athlete necessarily as an Olympic or a professional athlete. I just mean how close to the end user, I guess maybe is a better description. How close to the end user do I want to be? Right. And if it's, if the passion is way heavily weighted toward the sport and not quite as much toward the science, then you probably want to be looking toward a brand, that, has a good R&D team and you can get involved there. If the passion has a tendency to be, at the molecular level, so to speak, or chemistry or whatever that is, and that's what's really you love the end-use application, then you probably want to look to more up the supply chain to the materials component side, right? And then identify, then obviously, spend some time and see, which companies have worked together, which companies supply which companies, those kinds of things, and figure out, okay, well, who has a pretty big base? I mean, Gore, for example, right? They do a lot of work in a lot of industries, but obviously, have done a lot in the sports industry. So there's, Gore and BASF and 3M. I mean, all the big material companies have groups that, or products that are heavily used in the sports industry. And so, there's places there too. And we largely today talked about, stuff the athlete uses, but there's also, artificial turf and, all these other things that materials people are involved in too, that have a huge impact in the sports world.
I've done some innovation work in the past, but you've been doing it for like years and years and years, and you've been the head of multiple agencies. I guess just as someone who's done so much innovation, what advice would you give someone who's like me, who knows base science, but how do I apply it to a particular field I'm interested in?
Yeah, so I think the key is is, don't lose touch with your basic science, but also, for any new product that's going to come to market, that's got, some kind of technology involved in it, right? There really has to be a minimum of three things, right? There's got to be a correct user experience.
Mhm.
There's got to be a business case.
Mhm.
And then there's got to be some kind of technical feasibility, right?
Mhm.
And I think a lot of times what ends up happening is, people that are passionate about science or engineering, it's like they go all in on the technical side and, spend all their time, saying, hey, look, this works, and it will work, without really taking a step back or working with other people that are passionate about understanding user experience and the business case, right? Because, if you don't get sufficient overlap, some little overlap in that three-part Venn diagram right there, that's where you need to focus, is where that overlap is, right? And figure that out. So if the technology bubble's way over here somewhere else, and the business and use case is not intersecting, it's like, okay, you have a science experiment, not a future product, right? And that's all fine and good if that's what you're really trying to solve. But and if that science experiment leads to another project, it'll get you there, right? That's fine. But have a vision on the big picture, and don't forget about those other things. And obviously, there's a lot of times there's other circles that need to be part of that Venn diagram too. But for pretty much every product, it's got to be those three.
Nice. Well, thank you so much, Kim, for joining us today. I think David and I are avid sports fans, so it was really cool to see how there's innovations in our realm of material science as well. So if our listeners want to reach out to you or just learn more about sports innovation and material science in general, do you have any resources that you recommend?
Certainly the International Sports Engineering Association website. And admittedly, we're working on kind of getting that revamped now, but we publish a journal, Sports Engineering, and we have social media feeds on, Instagram and Facebook and Twitter. That's a great place to join those conversations and reach out to other like-minded people in that area. And just as a plug, we'll be hosting a conference at Purdue in June of 2022. So next summer. And on all the latest and greatest in sports engineering. Would love to see you there. Students, professionals, everybody else as well. We're going to have a lot of interesting side events, including a trip down to the Indy 500 track for a day, for a tour there too. So there'll be a lot of fun things going on up there. So maybe you can come join us there.
Thank you for tuning in to this episode of the It's a Material World podcast. If you enjoyed the show, consider subscribing and hitting the like button down below. If you want to meet other passionate material scientists and engineers, join our Discord community using the link in the description. If you have any feedback for us, we would love to hear it. We want to grow this show with our community's input, so comment below with your thoughts on this episode and what topics you want to see us cover next. We'll see you very soon, and in the meantime, go change the world.